The National Federation of Group Water Schemes recommends the following procedure in Unidirectional Pipe Flushing, UDF. The key to a successful UDF program is maintaining your assets before you flush a segment. Do a physical check on all the pipes, valves and hydrants in the segment. This gives you the opportunity to check and repair each asset before the UDF process starts. Then we have a managed schedule to oversee, maintain and lastly clean your network segment by segment on a continuous rotation. Failure to find weak points in each segment can result in pipes collapsing due to creation of vacuums. These vacuums can also pull in contaminated water if your network segment has not been properly assessed and maintained. It is vital to maintain each network segment before flushing. To ensure that waters supplied are safe and wholesome when they reach the customer's taps, keeping the distribution network clean is a vital procedure for every group water scheme. The sanitary condition of the distribution network is naturally affected by a buildup of organic or inorganic matter in reservoirs and pipes over time. This makes it harder for the chlorine to do its job, thereby increasing the risk of pathogens in the supply. Beyond this, they contribute to the formation of disinfectant residuals including trihalomethanes. In a perfect system, there should be very little loss of chlorine from the start of the network to the last house on the distribution main. But we know that even in a clean pipe, there is going to be some chlorine loss as it interacts even with the pipe itself. As a first step, group water schemes should establish target levels for total and residual chlorine at specific points along the network. This will provide a baseline for future management of the system. By measuring chlorine levels at these points, the operator will know if the rate of loss is excessive or acceptable. To provide further evidence, turbidity levels are a useful guide. Where water is clear of particulate matter leaving the treatment plant, then this figure should remain stable in a clean distribution network. This reinforces the need to establish target turbidity measures at various points in your network. Deciding when to clean your distribution network should therefore be informed by evidence. Measuring your chlorine and turbidity is vital.
There is a process that we carry out to make sure that we have all the boxes checked before Michael carries out a scouring or a full flushing of the mains network. Now, we have a little template done up, and it's just to keep a checklist that we have everything in order before he starts. The first thing that we do is we notify our members by way of a community newsletter or bulletin. We put information up on the community website. We also place ads in the local newspaper so that members are informed when this is due to happen. And then about 3 days or so before scouring begins, we send out a text message to members. We also notify our water services body in the local county council. We have a turbidity monitor and a chlorine monitor, and we check that those are in full working order before we start the process, that they're calibrated, the batteries, and all is in place before he sets off for his flushing.
Here we have a map of our entire network, and in this network map we have the area subdivided into district metering areas. We would work our way from the reservoir slowly but surely through the network in this area. But first of all, we will have identified all the valves in the area before we start this process to make sure that the valves are in a good condition.
Unidirectional flushing uses the highest velocity to scour out sediment and dirt from the edges of the supply pipes. The high velocity of the water carries the sediments with the flow to an open scour valve where the dirt can be safely released. Keeping the velocity focused to a single line at a time is the best way to efficiently complete this process. Schemes should be extremely careful that they are not agitating dirt in other sections of pipework when cleaning recently repaired or small sections of network like dead ends. In order to flush a section of network properly, the following minimum velocities must be achieved. 0.75 meters per second is the minimum required. 1.5 meters per second is recommended, and 3.0 meters per second to remove biofilm. You do need a flow meter each time to ensure that you are reaching the above outlined velocities.
Here we can see the equipment that we'll require for doing the flushing out process. Now, there is a lot of equipment here, and it is something that you try to cover all eventualities. You might not use all of the equipment today, you might not use all of the equipment tomorrow, but at some point you will need this equipment. And as a local saying goes, you're better looking at it than looking for it. I will bring a flow meter and pressure gauge, which we'd use for flushing out at the meter itself. Obviously then when we're doing the main scouring, we can use our fire hydrant, use a standpipe into a fire hydrant, which will be able to, with the aid of a hose, we can flush out that particular valve. And also a valve key, which is probably the most important thing we have, which we'll use on all the scour valves that we use. Again, another valve key, which is a smaller key. On our scheme here, we also have two small keys, which are for taking the lids off, which we will use constantly as well. We have our hog pump here. Any chambers that would be flooded, we can empty them out quickly and easily. Also, we have our shovels and brushes to keep everything tidy. If there's any overgrown debris, clipping around the valves so that we can have a safe and clear working area from local debris. Most importantly is we have our safety signs, which we will load into the van last because they will be first thing out on the road. When we come to a site of the valve, we need to put our different safety signs out along the road to warn traffic and pedestrians that there is somebody at work and that they must slow down and give everyone a safe environment.
Essentially, we need two numbers to calculate the scour time: the volume and the flow rate. Segment volume divided by segment flow rate gives us scouring time.
Here we have a flow meter. It will inform you of how much water flows through a section of pipe, so that you will know how long it takes that water to flow from A to B in that pipe, and then you will know how much water you need to use in future when you are flushing out that section of pipe.
To calculate the volume of a specific section of your network, we use the following equation: pi multiplied by r squared multiplied by L. Pi, because it's a circle, is 3.14. We use r squared, the radius of the pipe, in this case 0.05 squared, and we use the length of the segment, in this case 500 meters. We have 4 cubes, 4,000 liters in our 500 meter segment of pipe. Using the formula pi by r squared by L, we have calculated our volume to be 4,000 liters. And using a flow meter, we have established our flow rate to be 800 liters per minute, giving us a turnover time of 5 minutes. It takes 3 turnovers to flush each segment. Purchasing or hiring a flow meter is a vital step in establishing records for your water main maintenance. When you have a record of the flow rate and volume of each network segment, you then have good guidelines for the future. Did we achieve the required velocity of flow in the pipe? The recommended velocity is 1.5 meters per second. Therefore, we have to calculate the area of the pipe. Flow equals area by velocity. Area equals 3.14 by 0.05 by 0.05, which equals 0.00785 meters squared, or we'll round it up to 0.008 meters squared. Flow equals 0.008 by 1.5 meters per second, which is the recommended velocity, which equals 0.012 meters cubed per second by 60, which equals 720 liters per minute. At 800 liters per minute, the minimum velocity was obtained.
a comprehensive survey of the line in question before we start the scouring process, because when we start the UDF, we are going to be lowering the pressure in the line and possibly causing a vacuum. Thereby, we would pull in any contaminants that may be in an air valve chamber. So if we have done our checks and made sure that those valves are in good condition with no surface water, then we will have a clean line. And I'm just about to start the unidirectional flushing of the line. I've looked at the valve, and the valve seems to be in fairly good condition. So now I'm going to open the valve 1/8 of a turn just by cracking the valve open, just bearing in mind that keep your knees loose and your back straight. So I'm now just going to crack open the valve 1/8 of a turn, just to let the water start to flow, and then slowly I'm going to give it another 1/8 of a turn. Now I'm going to give it another 1/8 of a turn and just let it settle for 1 second or two. Now I'm going to start giving it 1/4 turns, very slowly. We can audibly hear the water going through the valve at this point.
Why are you doing it slowly?
To stop any damage to the line further down on fittings or pipework. There's a tremendous volume of water behind me, and to let a surge of water down the line could cause a lot of problems. And stop again. And again, slowly move it another 1/4 of a turn. And rest.
About how long do you leave it resting when you...
I will leave it rest for maybe 5 to 8 seconds between turns. Gentle change all the time. Better to be safe than sorry. In some places you can have an anti-clockwise open valve, and so you just want to make sure that you know what your valve is before you start the process. This valve takes 15 turns to be fully open. Now that can vary from valve to valve, but in this case it is 15 turns. So now I'm going to reverse the process and slowly close the valve in the opposite procedure that I opened it.
It is vital to close any valve in the distribution network slowly. Water is incompressible, so if a valve is closed quickly, the water has nowhere to go, and the energy of flow or pressure ricochets through the distribution system, causing structural damage and frequently failure, resulting in burst mains.
Here we have a dechlorination tablet, which we try to use and should use whenever we are scouring a valve into a water course, be it a stream or a river. We would try and have a container, which is a contact vessel, whereby we put the dechlorination tablet into that, and the scour through a hose would be directed into that container, and the dechlorination tablet would then eliminate the chlorine, dissipate the chlorine in that container, so that when it leaves the holding chamber, the holding container, we have chlorine-free water, which won't do the aquatic life any harm. Alternatively, we could use a hose, which we have here, and attach that to the tail of the scour pipe and direct that hose into a green field area away from the stream, and the ground will dissipate the chlorine in that water as well. It will have a similar effect, and that will eliminate the need for the use of a chlorine tablet. The idea is not to put chlorinated water directly into a watercourse, because chlorinated water is harmful to aquatic life, and we try to avoid that if at all possible.
Chlorine and turbidity readings should be taken every 3 to 5 minutes throughout the scouring process, as this indicates the profile of the water. The minimum velocity and times do not necessarily mean you have removed all the dirt. There could be a section of the pipe badly laid. The roughness of the pipe could be greater. There could be a valve incorrectly fitted on the line, and numerous other factors are involved. It is a combination of all the factors that lead to a complete flushing of the line. Know your network, valves, pipe diameters, pipe materials and scours. Plan the work, traffic management, work crew. Inform your customers. Assemble and check equipment. Work from the plant or the reservoir out through the network, that it works from a clean water source. Always have clean water following you. Open and close valves slowly. Close all valves and hydrants so that all of the water is directed at flushing a particular segment of the network. Use a flow meter to ensure you are reaching minimum velocities. Calculate the time to flush each segment of the network. Work to achieve 3 turnovers of the segment being flushed. Measure turbidity and free and total chlorine to know that the flushing has been achieved. Do not allow chlorinated water to reach a water course. Dechlorinate.